This is very exciting. Hi, I'm Dale Peterson, and this is the Unsolicited Response Show. Joining me on this episode is Sarah Fluchs with Admertia in Germany, and we have Vivek Ponnada, who is actually with GE up in Vancouver. So we've got quite a global session here with me being in Hawaii, but welcome everyone to the show.
Thank you.
I think,
hello.
Yes, I think we've got something very exciting to talk about here, because the reason you're both on is you're two of the leaders in an effort to develop the top 20 PLC secure coding practices list. And that list, this podcast is, or the show is going to come out on Wednesday, June 16th. So that list actually became formal. Version 1.0 came out on June 15th. So we actually birthed this thing. It actually, after all the work, it actually came out. It is out in the world and people are looking at it. And I thought we'd have you on to talk a little bit about it. Maybe just as a quick background on how we got here, Jake Brodsky for S420 submitted this session that said, hey, I've got these tips and tricks that you can do when programming or configuring a PLC that add a lot of security and resiliency to the system. And it sounded like a great idea. He gave the presentation, and when we looked at that, a lot of people said, that's very similar to what we see in other areas. For example, there's a top 20 list of secure coding practices for applications. And there's a lot of these lists that give tips and tricks to reduce the chances of introducing vulnerabilities, and again, to add more security and resiliency to the process. So since such a thing didn't exist, I think a lot of people in the S4 community said, this is probably something we should do. So we got a team together, and Sarah and Vivek were two of the people that really did a lot of the heavy lifting, but it was a worldwide, a global community. Quite a few volunteers pitched in. And over the last, I'd say 18 months or so, we've gone from nothing to this complete document that is now available. So it's very exciting. And I guess maybe a good place to start, since we created this list, is Sarah, who do you see as the type of person or role that needs to understand this information, know this list, and follow these practices?
Who we always had in mind for when we wrote this list was really the engineers, so automation engineers, or every person who programs a PLC. So people who not necessarily come from the security bubble, but who are out there doing the PLC programming, know a lot of stuff about PLCs and about the process, and always get told, have you thought about security yet? And we wanted to give them something in the hands, a tool, something concrete that they could use to answer this question with yes, and say, yes, we have thought about that because we followed these best practices that are important for security. So something very hands-on to follow, to implement security beyond frameworks and management systems, but something really covering PLCs for PLC engineers.
So it might be something that a classic OT security person might hand to an engineer or a technician or someone who's doing the programming, but it's not probably going to be the same person that is administering Active Directory or the firewall or something like that. It's really a different person. Or even
but unless you've got that unicorn that is an OT security expert and a PLC programmer, we don't want to exclude these unicorns. But at least I haven't met many.
Yeah.
So yes, it's more really the engineers that do something about it. And the OT security people, for those, I think it's really important to know that there's something out there, because I've seen many situations where people said, well, for example, there's that ISO control when you talk about doing information security systems, about secure system development. And I've seen so many conversations where people said, well, do you develop systems? Well, we do have PLCs and we program them, but that doesn't count as development, right? And we always tended to agree, because at the end of the day, what do you do? What if they say, okay, that counts as development? What do you hand them in order to cover that? We didn't have anything, our hands were empty. So people at OT security people rather tended to agree that, okay, that doesn't count as security, because we really didn't have anything to tell them. And that's what we wanted to change.
And Vivek, from obviously you're not speaking for GE here, but you've been involved in a number of things in the vendor's role. I also think there might be some use for vendors to look at this list in terms of, and I'm just thinking back to what Microsoft did with a lot of their secure coding practices. They started to make it easier for the vendors to help customers and integrators you do the right thing, and they made it harder for them to do the wrong thing through some of the defaults, through some of the compilers and things like that. Do you see, are there some of the 20 that you think might have some impact on the vendors?
Absolutely, Dale. I think you're exactly right. Some of the practices are features that are already available in newer platforms. However, they might not be default. So if the user base is asking for those things to be default, and the vendors, whether it's GE or other companies, can implement them, right? It's an easy putt for them because the features already exist. The other pieces, as an OEM or a vendor or an integrator, and sometimes all together combined, having features in a product doesn't necessarily mean it's implemented in a project, right? So again, if the OT security people or the asset owners are asking or demanding or putting that in the spec that this is the expectation, the intent is to have these kind of features, then same thing, these vendors or OEMs can implement them. And if they don't have a certain feature, they can either come up with a mitigation or implement it in their next revision. So there is definitely the same aspect that you described, whether it's Microsoft changing their posture from, hey, we supply the operating system, you figure out how to implement it, versus, in 2021, where they're proactively telling customers, what would be the ideal way to set up, what would be the most practical way to implement security. So I think that journey is a common journey for all of us in that regard.
Mm-hmm. Okay, let's dive into the list a little bit, and we're not going to go through all 20. And if you're watching this on YouTube, we'll put up some of the actual parts of the document so you can see them. If you are listening to this on the podcast, you really need to go to plc-security.com and download the list because it's freely available there. There's no login required or anything, right, Sarah? You can just download it. So
yes,
we don't collect any information, download it, use it. We'll talk a little bit more about the license later. But maybe rather than going through and talking about all 20, when I look at the list, I think of them, you can almost group them in certain types of categories of controls or coding practices. Sarah, maybe why don't we just start out by saying, what's one of the categories that really you think will make a difference, and give some people some examples of the things in there?
So first, you're correct in that you can group them into categories, and we actually spent some time on the project team talking about what would be good categories to group them in. And we've really thought about many different things, and then ended up with 2 general tags that we gave every practice. One is the security objective or security goal, and the second one is the target group. So first one, why, and that's the one how the entire list actually is grouped. So it's not like the first is the most important and the 20th is the least important, but we really group then by the security goals, because it kind of makes sense content-wise. So what the first security goal we have in there, and the most practices on the list actually are for this goal, and that is not a surprise, is integrity. Because obviously what you can do if you look at security for a PLC, or what the most important feature of a PLC is its integrity. So you can make sure that the PLC logic itself, the integrity of the logic is valid, and you can make sure that the integrity of the I/O values as valid, and you can make sure the integrity of the variables is valid. And that's the 3 integrity categories we have. So that is one. I think 12 out of the 20 fall into the integrity category. So, and that is not by, that's not, doesn't come as a surprise, and it's not by incidents or anything, but it's really, it's really the most, probably the most important security feature you can, in reality, achieve with a PLC. So
yeah, I'm just looking at some of these, like 8. So validate HMI input variables at the PLC level, not only at the HMI. To me, that one sounded very much like what you would see in an application list, right? To make sure that if the range should be 20 to 40, make sure that you're not trying to set it at 45 or something like that. That seemed very straightforward as something you'd see in any sort of coding or development. Were there any examples of things that were more PLC specific?
I think a very PLC specific one is, and also a very popular one on the list that many people liked, was to validate inputs based on physical plausibility. So because in that one, you really use specific feature of a PLC, because a PLC, the most important thing a PLC does is it knows the process. It knows some things about the physical process it is controlling, that's behind the PLC. So if a gate normally takes 5 seconds to open, and now it takes 10 seconds to open, then that's an anomaly, but you don't need any fancy anomaly detection for that, because you do have the PLC that does it. It's its job. It's exactly the job of the PLC to detect things like that. So if you know how long certain steps in the process normally take, the PLC really is predestined to find out and to alert about that, because it's what it's doing anyway.
Vivek, why don't you jump in here, and maybe you can comment if you had any other integrity ones that you really liked, that you thought were, some of your favorites on the list. I guess they're all important, but some of your favorites, and then maybe throw out another category that you see in the list if you were going to group them together.
Sure. For the integrity piece, my favorite one is the validate and alert on paired inputs or outputs. As in, for example, if there is a start, there cannot also be a stop at the same time, right? So whether it's on the input side or the output side, that's my favorite one, because you can validate that pretty easily. Like if you are able to give a start command, you should not be able to give a stop command. Or if you're getting an open feedback from the limit switch on a valve, you cannot have a closed limit switch at the same time on the same valve, right? So those are easier things to implement in the PLC. It's already there in probably the same rung. It's just a matter of alerting that, hey, these things don't look right. So that could be malicious. It could be a problem of the limit switch in the field, but that's another step that's down the lane. But at least upfront, you'll know that there's something wrong with this operation on the integrity side.
And I think it's important to note there too, because that was something, not being a PLC programmer, I was surprised that such a thing was possible, that you actually had to program it so it didn't work that way. Right. Because I would normally think it would be a single variable that would be on and off. I didn't think that it would be 2 separate tags or points or something like that. But I guess in many cases it is. So that's an area where it might not make any sense to someone thinking about it from an application security standpoint, but from a PLC security standpoint, it makes a lot of sense. Sarah, did you want to jump in? Did you look like you had a comment, or no?
No, I'm just saying that I think that's a very important point you're making, that many of these things don't look like something someone from an application security or from a normal security background would even consider relevant, because it looks so simple. Actually, we have these kind of comments from 2 directions. So first, the normal security people saying, well, some of these things look, they're too basic. Why do we even put them in there? And then we're saying, well, because the target group is PLC programmers, and they're not as deeply rooted in security as you may be, and maybe they're doing all these things but don't even realize they are security relevant at all, or they don't do it, or they cut it out and don't realize they're cutting out something security relevant. And then also the second group would be PLC programmers saying, well, but see, this is something we've been doing for ages anyway. Why even put it on that list? And we're saying, well, first, because you may be doing it, but there are new generations of programmers coming after you, and we want to make this knowledge accessible. And the second would be, well, and you're doing that, and maybe you're even aware that has a security relevance, but maybe others aren't, and maybe we should all have a common understanding of what we think security in PLC coding actually means. So what kind of features are actually meant when someone says, I want to program my PLC securely? Because I don't think there's any consensus or any kind of discussion at all about that. And that's something that we want to get started with that list.
Yeah, one that shocked me just kind of as an outsider to the field was the validate timers and counters for reasonableness. So basically that things weren't counting backwards, that you weren't time traveling. And I thought, well, why would you do that? But it's a programmable device, so you could program it to, you could change the setting potentially if you're not validating that, all sorts of crazy things that could happen, both from an attack scenario and just a cyber incident, just things going wrong could happen. But Vivek, we kind of cut you off there when we dove into those. What about another category? So we hit the integrity. What's another category that you think listeners should know about?
Yeah, monitoring is the other one that I really like because that's pretty basic, right? So a couple examples there, the PLC cycle time, like how long does a particular subroutine needs to function, the time to execute, or, how much memory a PLC is consuming at any given point, or how much CPU usage you have on that PLC in general. So these things are, I guess, available in many PLCs, but hardly ever trended on the HMI. So if you don't trend it, if you don't log it, then nobody's looking at it, right? CPU usage, for example, is a variable that's available. You can always document it, you can log it, you can trend it, but very rarely do you see that on the operator screen. And that's an easy place for an operator to see something is wrong. So, these PLCs are deterministic. That's the whole purpose of an industrial control system. You kind of have predictable cycle times and memory usage and CPU usage. If any of these are different for a day or for a particular period, and if an operator can see it and then alert the controls engineer or the process engineer, then they can take a look at it as to what's wrong, what changed in the system. And again, that could be malicious, that could be some other configuration error, but it's easier to find out if you're trending and logging it. So we use monitoring as that's another popular one. I think 5 or 6 of the practices belong to that category.
Yeah, I saw
that. And also,
that.
again, that is not security monitoring, right? So we're talking about monitoring and detecting anomalies so often, and we have fancy extra appliances for that. But these are things that a PLC can do, and these are things that may be monitored anyway. But we just wanted to make a collection of things that you can monitor in a PLC, and many people may monitor anyway, like cycle times, but that also really have a security relevance and a security benefit if you monitor them, because you can draw conclusions from them.
Mm-hmm. And now I'm going to put up on YouTube, I'm going to put up the more detail behind each one of the practice here as an example. And if you're listening, just go to plc-security.com and download it and look at it. But each one of the practices, so there's a top 20 list with a short sentence or two for each practice. And then the team that developed this actually went through the work to put something behind each one of those top 20. So for each one of the top 20, you have as Sarah mentioned, you have a security objective, which is a broad, kind of similar to the categories we've been talking about. Then there's a guidance, so a few paragraphs explaining it in more detail than just the sentence. Many of them will have an example, right? Actually, I think most have an example now as to how you'd actually implement this. And then there's a why section that talks about the benefits from a security standpoint, a reliability standpoint, and a maintenance standpoint. And the maintenance one came up a lot. I think that was a big thing with Jake. Jake, who started us all out, always was pointing out maintenance benefits. But do either one of you have an example of where one of these practices would help with maintenance? Because that might be something people would normally think about for secure coding practices. Putting you on the spot here.
No, not at all. For example, leaving the PLC code or operational code in the PLC as much as possible and not in the HMI. That's a great one for maintenance because, to troubleshoot, right? Like obviously when you're doing maintenance, we have two kinds of people. We have the operators and then we have the controls instrumentation technicians or the engineers. So when an operator is not in the picture and the maintenance engineer has to troubleshoot something, that's a different level because there might be a permit required. There might be a blinking lights thing, and someone needs to go in, connect their toolbox or some kind of interface to check what's going on in the PLC. So a lot of these in integrated codes or something that's in the HMI is very difficult for an instrumentation controls engineer to troubleshoot because it's not in the PLC, it's not logged properly, it's not portable. You can't take it from one location to the other. It's not easily available in the engineering workstation because it's on the HMI. And usually you need the HMI type software, Wonderware or Simplicity or something like that on your computer to be able to open up and check the code, which is not always the case. If it's in the PLC, then it's in the runtime code. You can connect your toolbox and download it and easily troubleshoot it. So, and many of these are that way where you might think logging something or understanding how the CPU usage, as an example, is happening. It's a lot easier to troubleshoot what's going on in the PLC or the I/O for that matter, and troubleshoot at that controller level, versus not having that option and having to do that in the HMI, which you can't take an outage and you don't want to take the view away from the operator. So two different roles, but maintenance engineers love a lot of these practices. In fact, most of the implementation of these practices we think will happen because of those maintenance benefits and less so because of security.
Interesting. I was trying to get a handle here because, again, I don't come from the world of programming or configuring PLCs, sometimes fuzzing them and doing other things to them, but not actually trying to make them work properly. So my question, I guess, would be, and maybe Sarah, you can start with this. How universal do you think these are? Of these 20, do most of these 20 apply to most of the PLCs or level 1 devices, or are they more applicable to devices that have come out in the last 5 years? I'm curious about that.
I even sometimes have the feeling some are more applicable to those that have not come out in the past 5 years, because many people during development said, well, we actually have to do more with PLCs that have come out within the last 5 years. And there's also been practices where people are saying, well, the very new, very modern PLCs maybe don't have these problems anymore. But the time until we're there, that we don't have all the old PLCs anymore and just the modern ones, is just very far ahead. So it doesn't make sense to exclude the old ones. That said, we aimed at formulating practices in a way that they are as universal as can be if you regard central PLC particularities. So you say, okay, a PLC is a device that operates in real time, that is controlling the process, that has certain ways of working, so cycle times and certain scan cycles it follows. And for these, if you take these as a major framework of what a PLC is, I think they are applicable. One thing that I'm not entirely sure if they're universal, but I'm very curious to find out, is how universal they are regarding different PLC vendors. Because obviously we took from the community whatever we could. So whoever had a good suggestion for PLCs made it. But naturally, most people have a tendency or just more experience with a certain kind of PLC. So that's also a regional difference oftentimes. So if you talk to German people, they've done a lot of Siemens. If you talk to American people, they've done a lot of Rockwell. So that's just a difference. And we noticed that sometimes a PLC came, for example, from someone in the US being familiar with the Rockwell PLC, and someone in Germany said, why would you even think about that? That's automatically in here. And that doesn't mean to have, it's just an example. It doesn't have to mean that Siemens PLCs are better, but it just shows that there are differences and that there are issues that are really big issues in one vendor's PLC and may not be as big in other vendors' PLCs because they're just solved in another way, and people don't run across it that often. And that could also be from one industry to the other, that there are differences. And that is something that we obviously don't have. We try to make them universal, but we don't have a broad range of having covered every PLC for every vendor. And we're really curious how certain vendors react. So that would be one of my things where I would really hope that vendors jump in and look at this and tell us either what are you even writing down here? We've been following that for years. Then all we have to do is tell them, well, then start and communicate that better, right? Because no one knows. And also, if you're doing that, and the operators and the programmers, the asset owner, are not using these features, then maybe you're not doing that well enough. But maybe they also start thinking, and that is really something I don't have a good feeling for how vendors will react, because I have the feeling we didn't have a broad range of vendors on the project. And I'm really interested in how they react and what they think about this, and in a neutral way. If they say, well, 19 of the 20 don't make sense at all, and they add and this is why, and this is what makes sense instead, then they're totally welcome. So we would be totally grateful for that kind of feedback.
Yeah, I partially disagree with the universal piece, because I do think all these are universal. But I agree with Sarah that the vendors that were not participating might have different ideas and different implementation. What we try to do is provide themes, right? Like, this is what we're trying to get to or achieve. Now, how you achieve it might be different in a PLC versus another PLC. In fact, a couple of examples actually do say that. Like, for example, memory usage in a PLC, might be a variable available in Allen Bradley, might not be a variable, but you need to configure that as part of a logic in another PLC. We try to use some examples that way, and that's why I think all these 20 are universal. But a certain vendor might already have, a cryptographic hash available. They might already save itself on the HMI, so they don't need this practice to tell them to do it. It's already doing it. Right, then they might just say, yeah, this practice, we comply with it, or we execute this anyway. So I do believe that these are universal, but what we don't know, right? Like, we had several dozens of people contributing to this project, and we had several practices that we did not include because we didn't think they made the top 20. But there might be something else out there that's a best practice or a vendor specific thing that is pretty cool and maybe needs to be adopted across the industry that we don't know or we're not aware of yet.
Well, the vendors bring up a good point, and this is something that we talked about from the beginning. The people that started this project, the two of you on the call, Jake and some others, that we wanted whatever came out to be as widely usable as possible. And so Sarah and some of the lawyers in her company helped us come up with the actual license for this. And when you read the license, of course, it's a legally written license. But if I put it in simple terms, you can do whatever you want with it. You can use it, you can modify it, you can build on it, you can do whatever you want with it. You just have to include this little text at the end of it that's, that recognizes that you got it from this project. You have to include a little copyright. And we actually have an early example of this with the ISA GCA putting this up on their site, and they're free to brand it however they want to, as long as they include that thing at the bottom, because our goal really here was to get this out to the engineers and technicians and people who would use it, rather than create some piece of money-making intellectual property. The goal is really to get it out there. So we've even talked about perhaps some of the training courses, including this as a module, which would be great. This could be a vendor course. This could be a ISA course, a SANS course, a brand new course by, someone focused on PLC security. The vendors could create their own documents around this, right? They could say,
what we would really like to see is if they say, right, this is the list and this is how we interpret it, right? If you're looking at our PLCs and at that list, see, that's how we're doing it. So that would be perfect, yes.
Yeah, almost as a way of a secure deployment guide for their system that meets the 20, and here's how they meet the 20, something like that.
Yeah.
Yeah, that would be fantastic.
But what I don't want to happen is, we see this all the time, right? What we don't want is a consultant coming out and saying, if we had our product, this wouldn't happen. Because I see this all the time. As an example, right? The track operating modes, we're saying, don't leave the PLC in run mode. And somebody out there will put out a document saying, if we had our PLC, we don't have a switch. So, use our PLC. The intent is not to say one PLC is better because it has this feature. What we're saying is, if you do have this feature where it has a run mode and a programming mode, make sure it's not in the programming mode, right? That's what we're trying to say. There are others down the list that way too, and sometimes it's kind of interesting. The examples we talk about, whether it's the Triton example, where this particular case was relevant, where it was in programming mode, right? Or another example for Oldsmar, Florida, where you could enter whatever value in the HMI, and invariably you'll see engineers that are proud of their programming and coding capability, questioning that one person that did the code. Oh, that integrator did this incorrectly, or how could they code this so badly, right? But the thing is, we have vendors, we have integrators, we have users, we have so many people involved in these projects that oftentimes in the name of efficiency, in the name of getting things done quickly, you do whatever is strictly necessary to get the functionality. Any of these things will take time up front. Right now, you will take less time during troubleshooting, you'll take less time during maintenance, you'll take less time during incident response, but those are all after effects. Those are not the reasons why people code these in the first place. So that's the one thing that I hope won't happen, as in consultants won't come in and claim that having their product or a solution will fit better, and then some of the others question why others are not doing this, because there are good reasons historically for not doing these things, because these take time, a little bit more time and nuance up front compared to later.
If anything, we're hoping it's a cookbook for dismantling such like marketing statements. So if someone says, see, I've got a secure PLC, we can say, okay, if I would regard something as secure PLC or secure programming features, I would expect this list. And you can double check and check back and get a common understanding of that, and not just have the marketing claims. So what I wouldn't like to see is, and that is, it's not a standard, right? So we don't have a standard, and you can't be certified against that list, which probably is a good thing, because what I don't want to see quickly is like top 20 badges on all products, and in the end, I would like to see that if there's also that document saying we've got the top 20 badge, and here's how we manage to do it, and how we help you, the asset owner and the PLC programmer, to actually use these features, because you can't have a secure PLC by design. It also, all these features have to be used and have to be implemented, and it doesn't have if there's just badge on the product and no one knows why. Exactly.
Yeah, and I think it's really important to differentiate between, this is not a list that says these are the security features you want in your PLC. For example, we don't talk anywhere here about authentication of the
because you can't achieve that by programming.
So yeah, exactly. Yeah. So this would not be a list to say this is really more of the integrator, the engineer deploying it. This is something maybe you would include in a FAT and a SAT and some sort of acceptance testing to say, this is what you were supposed to do when you programmed it. Let's actually verify that you did include these things in your system. So it would be
an important point. Yes. So it's less capabilities. It's more what you can do with the stuff that's there, even if it's not perfectly capable of security features. But anyway.
No, that's great. Now, how do you think, this is where I'm at a bit of a disadvantage again, because I deal primarily with the OT security professionals and maybe to an increasing degree with some of the executives, but not, my audience isn't so much the engineers and technicians that put these out. The S4 audience, there's, as you say, some unicorns and some people that are just curious to come from that arena. But how are we going to get this out to that community? What kind of ideas do we have beyond ISA helping is obviously a big thing. Who else, maybe instead of putting you on the spot that way, who else would be helpful, do you think, in getting this out to the people that need it?
Well, one big group is vendors and their users, because they know who the people that implement, that use their products, and they sometimes have users groups. As far as I know, I think Vivek knows more about that and can have details. And all kind of engineers associations and meetings like ISA is, I think, are a good place to put that. And those are often local meetings. So it's not like we don't have to put that on the big 3 cybersecurity conferences. Well, but not only there, because it's a good, we do achieve something if we teach the security people that there's something, because they can hand it over there and they can maybe just start dismantling the myth that PLCs can't be secure anyway, because we want to make obvious the PLCs as they are, they don't have to be changed. You can do something for security. The myth that you can't achieve integrity checks with a PLC is really just a myth, because we've got 12 out of 20 practices that help achieving integrity. So you don't have to have security products doing that. You can do something with a PLC on hand. But that's just one half, and the second half really is the engineers that program it. And I'm hoping to find these at vendors and users meetings, at engineers associations. If anyone listening has ideas, then please come up with those and take the document, download it, and take it there, because we really need these ambassadors.
Yeah, my feel definitely is that it should be a user pool, because some of the more modern PLCs have a lot of security features that are not implemented, that are not documented properly, or even if they're all documented and available, due to time constraints or budgetary constraints, they're not implemented because they might take extra few days or engineering hours to do, right? So I think the biggest pull will be from the users. So our goal is to educate as many users as possible, whether to reach out, with the ISA team, or regional chapters, or the user groups for different control systems that we have out there. Because when a user is asking the question, or is including that in the specification, or demonstrating that intent when they're talking to the vendors and salespeople, that's when these things get incorporated, because then the vendors and the integrators know that could be a differentiating factor if they put that in in their bids or in their execution plan, and it'll be looked upon favorably. They might get better points in the bid evaluation. So I think the biggest pull is going to be from the users asking and demanding that more secure practices be followed in these coding practices.
Yeah, and I think one thing that was interesting as we went through this, and maybe Vivek, you can speak to this, is we had some practices, we had some scoping questions. Like there were some things that were really good ideas, but we said were out of scope. Can you maybe just point out 1 or 2 areas where we said, yes, this is a good idea, but it is not a PLC secure coding practice? And we did capture all that information. We didn't lose it, but some things that maybe aren't on the list that people would think on the list, and why they were scoped out?
Sure. Yeah, my favorite one is the power supply one. So one of the suggestions was, monitor power usage of a PLC or the control system. And if you're seeing spikes in it, for example, if someone maliciously was operating valves and maximizing the current on the output, you can get that from monitoring power consumption. But when you look at it, it's not really a coding practice. This is more of a system-wide thing. You need to be able to monitor the I/O power consumption. A lot of variables go in. I mean, even in a normal plant operation, which includes, startup and shutdown, these valves are being driven, so maybe milliamps on an I/O board is different, during different phases of the plant operation. So you need to monitor that at the bigger picture I/O level, environment level. So we kind of have to exclude that because it's not part of PLC coding, but we capture it because it might be a better fit for what could be a PLC environmental practice list.
I see. And then, Sarah, maybe to finish out going forward, people are going to download the list at plc-security.com. But then, Sarah, if someone has a comment on this, how would they get us a comment? Let's say if they said, we think it could be improved this way, or here's another practice. How would they get the comments? And then I know we just put version 1 out, but do you have any thoughts as to what the future of this list is? Is it something that will be updated? How will that go about happening?
Yes. So we obviously, since we started the project, we rely on a lot of people with a broad experience and differences in these experiences to comment on that. So we definitely want people to comment on the one we have here. We originally planned to have a version before the 1.0 version out, but then it was mature enough to call it 1.0. So here it is. But that doesn't have to mean that it's really, it's fixed that way. So it's a living document, and we really want people to comment on that. So if you read it and think, well, that I can do that better, then please do. And the easiest way to do is we try to make it as easy as possible. On the same web page where the document is, there's also a link to download the comment form, so you know what kind of questions we would ask you, and can provide as much as you can to that form. Don't worry about if it's not complete. Just put in everything you can, and send it to us. That's the easiest way. That consumes almost no time. And also, we would be really happy for all people who want to get further into discussion to join us. We've got a small core team of a handful of people that maintain these practices, that care about the next versions that will come out, maybe yearly or so, depending on what kind of comments we get, but also that decide about where we strategically go. So if we collaborate with other groups doing something neighboring, like MITRE or CWE, who proposed something and said, hey, we can do something. We can do a PLC weaknesses list because we haven't PLCs covered well, for example. Or we work on that second environment list. Or we just talk through the comments we're getting in detail and decide how they get into the document. And that all is done in that core team that's going to meet after the document has come out. And we're always looking for people with good ideas, or who are just curious to join and to help us out there. So first way, just download the form and send it to us. And second way, if that's not enough for you and you want more intense collaboration, then come into the core team. We're totally open for new people there.
Well, that's great. And I should note that there's also a Twitter handle now @SecurePLC. So if you want to follow announcements beyond seeing them on the website, you can go @SecurePLC. There's going to be a number of presentations done. I think some people on the team will be on various podcasts besides this one. So we will be trying to get the message out there. And if you're interested, if you have a community that might be interested in hearing about this, definitely, send a DM to @SecurePLC or put something out on one of these comment forms. We'd be happy to support you in that. Maybe as kind of a finish line here, and I really appreciate all the work you did, Sarah and Vivek and Jake and many of the others. There's a supporters page on the document that lists the people that actually helped, and there were a lot of people that helped at various levels. I know, as I said, the two of you did the heavy lifting. I felt a little guilty. I knew this was something we needed, and I knew I was completely unqualified to play a major role in it. So I kind of just threw it over and became a cheerleader for it. And I was so happy when the two of you and some others picked it up. But maybe as a closing piece here, is there something important that we didn't talk about related to this list that the listeners or the viewers should know? And Sarah, you can say nothing. We covered it all. But if there is something, that here's your chance.
Whereas one thing that we want, that is expectation management, maybe. So if you're wondering if this would have stopped Stuxnet, then we have to say no. Unfortunately, no. If we had that solution that would have stopped Stuxnet, we wouldn't do it for free and do it sitting around in this podcast, but just apply for the Nobel Prize or something. So no, it doesn't, because really the scope is really limited to everything you can do to a PLC, that involves changes in a PLC. And while a PLC is a very important part of OT and of the entire process, it is still only a PLC. So don't ever overestimate what a PLC can do, but don't underestimate on the other way that a PLC can contribute to security. So we have to, it's not the silver bullet that will solve all your security problems, but it was just a big empty hole where we had nothing at all. And it's probably not even the best, if you don't do anything about security yet, it's probably not even the best way to start securing your PLCs, because there are a lot of low-hanging fruits to cover first. But then the PLCs, if you're starting to wonder how you can secure your ever so vulnerable PLCs, at least you do have something in your hands now. And don't follow the myth of PLCs are always insecure, because there is something you can do about that. So that is something that would be important for me to mention, just in case.
Yeah, it's funny you say that, because I know Kelly Jackson Higgins has an article out by the time this show comes out, and she talked to me for a little bit about this, and she said, now I'm almost embarrassed to ask this question, but I have to ask, would following these top 20 have stopped ransomware? And I was like, no, it has, because, obviously if you can tie into the ransomware angle, that's very hot today, but this is not related to ransomware on PCs. That's not going to help you at all with ransomware on your personal computers, your servers, your workstation.
It could stop some of the collateral damage though, right? So it could make the PLCs more robust to at least not be simple victims for collateral damage. But if that's ransomware, that's ransomware, right?
Factors, right?
That's a bit of a stretch. But yes, you could make that argument. So Vivek, why don't I'll give you the last word here. Is there something that the listeners, viewers need to know that we haven't talked about the list, or something you want to highlight?
Yeah, I think one of the important things is this is not a monolithic, big investment needed in all the practices. Of the 20, probably half of them are easy to implement even at the user level. You don't need to go back to the vendor or the integrator to get this done. Trending, for example, the cycle time, or disabling unneeded communication protocols. You can do it at your, in your own spare time at an end user level pretty easily. So it doesn't always have to be a greenfield or a brownfield upgrade project. You don't have to wait till the next time you're upgrading the PLC code or upgrading the computers, making the network better or something like that. You can do several of these things today. So if there's one thing you can take away from it, is just take a look at the themes, overarching themes of these practices, and see what can be implemented relatively easily with minor investment in time, not even dollars, and several of these fit in that category. So that'll help yourself, with having logs, with maintenance and reliability, and as a side benefit, helps in instant response and security benefits. So taking it from that angle, that this is going to make your own life as an end user, as a controls engineer, as a process engineer, your own lives easier on a day-to-day basis with very little investment in time.
Great. Well, I think that's a good place to end. Sarah and Vivek, thank you for being on the show. Thank you even more for doing all your hard work in helping this list become a reality. I'd encourage everyone to go to plc-security.com, download the list, and follow @SecurePLC on Twitter. Anything people can do to help us improve the list, and probably more important here over the first 3 to 6 months, get the list out there. Get it to the people who need to know it. Get it in training programs, get it in vendors, get it in asset owners. We really need to leverage this hard work. We don't want it to be a document that just sits there and gathers dust. We want it to be a usable document.